I'm Kimberly Schonek. I'm with the Nature Conservancy. I've been working in the Verde for about 5 years now. So I'm not going to talk about invasive plants. We're going to talk about ditches and water use in the Verde Valley. So just to give you a little perspective on where this is, you can see the state of Arizona. I have to refer back to the diagram that tells me where the laser is. So we're right in the middle of Arizona. Here's Phoenix. The Verde flows across here and then south into Phoenix. There's a lot of facts about the water. I think one really important fact is it serves water to 3.5 million people. So it's drinking water for the Prescott area, which is a large community up in the top of the watershed, all of the Verde Valley, and then it's about 11% of the overall water supply for the Phoenix area. So it's very important to the state. It's also very important ecologically. About 85% of the region's wildlife depend on it at some point. There's 2 populations of breeding river otters in Arizona. One is in the Colorado River and the other is in the Verde. So the Nature Conservancy completed a conservation action plan 3 years ago, and we really looked at different threats to the watershed and what we could do about them. These are some of the things we came up with. And we identified invasive plants and animals as a priority, but it wasn't a priority that the Nature Conservancy wanted to take on. We wanted to focus on groundwater pumping and surface water diversions as our 2 areas of expertise, because we had a lot of partners who were working on other projects. My particular work focuses on irrigation water diversions. It relates back to the groundwater pumping, and hopefully the 2 systems will someday be more integrated. But this is just an example of one of the irrigation diversions that we have to give you a little perspective. They're different than, some of the ones you see here in the Colorado. It's a dirt push-up dam. So this is the dam coming across the river. This is very little water. I come from Oregon, so for me this is dry. I don't consider that to be a flowing river. And Arizona, it's a little bit of controversy. It's dewatered. This is the irrigation diversion after a big flood. So our diversion dams wash out at least once a year, sometimes twice a year with monsoons, and then they take large tractors back in and rebuild these structures. So we have the impact of having water taken out for irrigation diversions, but we also had a lot of disturbance associated with these diversions. This is just another dam to give you some perspective. This is the ditch, and this is the river. So we have a loss of open channel habitat. So if you are a fish and you are downstream of this diversion, you cannot get back upstream. So there's several places on the Verde River that are completely segregated for fish, or separated. This particular one, when I first came to the Verde, I walked down to look for the river, and I got to this spot, and I wondered why there was concrete in the river. And I think a lot of people who float this stretch often wonder, why is there concrete? And then you get to a culvert and you realize this is not the river anymore, you're now in a ditch. And you've gone past the river and not even noticed. So irrigation water use in the Verde. We have about 5,380 acres of irrigation. So that's not a lot in terms of the systems that a lot of you are talking about. It's a very small area. It mostly irrigates small properties. So 50% of the water is used on small 1 to 2 acre, up to 5 acre parcels. So that's a lot different than if you're working on large farming operations. When you're looking at farms, you can talk about how water efficiencies will improve their operations. But when you're talking about somebody's Bermuda grass lawn, there's not a lot you can say to them about efficiency. When people use 1 acre of water, they think, I'm not the problem. But if there's 3,000 of them, they are all collectively part of the problem. There's 7 large ditches on the main stem. Right now we're actively working with 4 of them on the main stem, a couple on tributaries, and then kind of passively working on some others. Some of these ditches divert 17 times more water than they consumptively use on a crop. So they just take the water in because that is how the system is structured. So we'll see a graphic here in a moment that kind of gives you an illustration of how that works. But what I really want you kind of to see is these are small little lots, and we have a couple very large farming operations that go with them. Just a couple more shots of the valley. It's a very beautiful green place. There's a lot of habitat for birds along the river. There's habitat along the irrigation ditches. There's, small little farms, little orchards. This is the predominant water use in the Verde Valley. You flood irrigate your front lawn and grow Bermuda grass. This is a very bad example of how to do it. This is the Eureka ditch, and we're going to talk a little bit more about this in a minute. So what you see here is actually the whole ditch system. So this is the one large farmer that we have, and then all the way up through here are the small houses. So when we talk about water efficiency in this ditch, it's really hard to talk about farming efficiency versus how to irrigate your lawn more efficiently. And so we have very incompatible uses. So one of the projects we've actually talked about is how do you separate incompatible uses. What this means for the river, if you're a fish, you can't swim upstream. And if you're a boater, it's really hard to float downstream. I've had some very terrible floating experiences where we've carried boats for miles, and often people don't want to go boating with me. My interns never want to come back with me. So what we've done at the Nature Conservancy over the last few years is to start understanding the overall system. And we also wanted to bring the irrigation companies along with us on this understanding. Just because we understand it doesn't mean we can change it. We need the people who actually manage the water to understand the water. So we've put out water measurement devices. We've been working with the ditch bosses to irrigate them on how the instruments work. So it's not enough to just say, yeah, we know how much water the ditch is using. We need the ditch company to know how much water they're using. We need them to know how much water they need to use. So we've done things like install staff plates that just show you the depth of water in the ditch and how much flow that is. Most of these guys are not professional water managers. This is what they do as their spare time, as a part-time job. And so they don't know what 3 CFS means. But they know that if the gauge says 3 CFS at this particular location, no one downstream of that is complaining. So that's where they need to keep it. So in some of these ditches, they're just have for ages gone out and eyeballed it. They said, oh, well, that's the rock I keep covered. And when that rock is covered, nobody complains. So we're trying to just upgrade the technology slowly and to look at a staff plate and actually measure. And the other project we started on were water management alternatives. So actually looking at individual ditches and seeing how could they get their water more effectively. Could they pump the water? Would lining the ditch work? Would piping the ditch work? What did we need to do? And how much would it cost to do those? We also looked at what we could legally do to protect the water. And in Arizona, there's very little we can actually do to legally protect water that we could conserve. So we have to take that into consideration. We started this with the Eureka ditch. And what we really learned was if we were to do some of these projects and implement them, we had no way to protect it past other irrigation projects. So we have to make sure we're working with all of the ditches so that it's a combined project. So here's just some examples of things we can do. Using pump stations. So in some cases, it's actually feasible to pump the water at the same cost as it is to deliver it via gravity. That's generally not the case. But in some of these situations where you have 4 or 5 miles of just conveyance, that does work. We've looked at piping. Piping tends to be very expensive. We've looked at automated head gates. Some simple things, only taking the amount of water you need. So if you can determine how much water you need, just take that. And then scheduled use, which is not very popular. We're going to skip this table. It has to do with a model that we're not going to talk much about. This is a map of the Eureka ditch. It is this orange line, and this red line is another ditch that takes out water below it. That red line ditch takes out all of the water in the river. It doesn't matter how much water is in the river in the summer. If it's there, it goes down that ditch. That's that second ditch we looked at. There is no bypass structure at the point of diversion. It goes down the ditch for about half a mile, and then they dump the extra back into the river over an 8-foot drop. So that's not a good situation for boats or fish. Looking at ways to incorporate recreation into this and finding funding in that way is, I think, a very interesting idea from yesterday's presentations. So the Eureka ditch, it's 8 miles long, purely conveyance through here. So some of the alternatives we're looking at with them are actual pump stations, lining, reducing their tailwater. Although these are rather hard to implement, they're going to take a little bit longer in terms of the legal issues around pumping and moving water. Some of the projects we've actually been able to implement in the last year are to automate head gates. So this ditch company takes about 4 times more water out of the river than it needs, and it typically takes whatever is in the river in the summer and then dumps whatever it doesn't need. But they haven't been very proactive at managing it. So this ditch flow can range from about 28 CFS up to 45, depending on how much water is in the river. Their demand does not change abruptly. They just don't go out and change the head gate around. And you can see this guy jumping on this blade here. That's how they would lower the gate. It generally, to be safe, was a 2-person job. Someone would loosen up the cables on the other side, and he jumps to push it down. So it's not very safe. It's not very fun. No one likes to do this job. So they didn't adjust it very often. So we were able to invest in some automated head gates to actually control their flow. So this ditch used to flow between 28 and 45, depending on the day. Last summer, we were able to operate at 28 CFS all summer after getting that in. So we saved quite a bit of water with this project. This year, what we had hoped to do was to be able to pay them to reduce their diversion even more. And by having this gate in, we were able to experiment with lower flows in the ditch. And what we learned was some of the takeouts are too high up in the ditch in order to actually reduce the volume of water. And the reason that they run too much water is they need depth. So we were putting in check structures this winter. This is an example. All this will do is back up water so that the level of the water will remain here, and that will cover this outtake. So with that outtake covered, we think we can reduce the flow in this ditch by another 5 CFS at least. And then hopefully over time we can get them down closer to their consumptive use rates. We wanted to kind of look at what this meant as a system. So there's a lot of little projects we can take on, and we want to know what that means in terms of flows in the river. So, hold on, we missed the slide. Or it's not in here. Okay, well, there's a really great slide that we missed. So we'll talk about it here. What you can see is this purple line is what the flow is like in the river. So when you're coming down the river, this is about the middle of the Verde Valley, the flows drop off significantly at the first irrigation ditch. They come back up with the return flows from that ditch that are really close to the top. The next ditch comes out, the flows drop off again. There's return flows that come back in. This next ditch takes them all, and then the flows come back up, and yet again the flows drop back off. So the ditch company at the bottom, this is the Diamond S. So this is the one we're working on with check structures. And you can see here, this flow is down under 20 CFS. What we think we can do if we put in check structures and automated controls is to actually reduce the amount of tailwater that comes out of the ditch and somewhat start to, alleviate this line. So we predict with, these projects in place that we can bump the flow up by that amount. This is some further modification of the ditch, so actually having the control structures right at the points of diversion, which is a little harder to do in our system. It's very flashy. So this is a natural flood regime, so it can flood in August, it can flood in June, it can flood in the winter. So we don't know quite what to do about those structures right in the river to make them work. But once we figured that out, we think we could get a little bit better. There's also some ways around that in terms of building flumes and check structures through the diversion dams themselves. So that's my 2 graphs. Otherwise, I have pictures. We are investing a lot of money in infrastructure. We don't want to just put infrastructure out across the watershed and not get any return on our investment. So we don't want to say, here's $75,000, go build some check structures, put out some turnout gates, and we hope you use them. We actually want to train these guys to use the systems that we're putting in place and provide some incentive. So we've raised some funds to do incentive targeting, or incentives to target flows. So with the Diamond S this year, they actually will get paid to conserve water. They can get up to $20,000 in payment if they reach their flow target of a reduction of 5 CFS. It's going to be work for them socially. They're going to have to pay a ditch boss to go out and pay attention. It's going to be a little bit different than how they've ever done it before. So we hope this works. We hope we can extend this over the next 3 years and really get them to a place where they've invested enough in their ditch that they don't have to take extra water, that they can just use what they have, and that they know how to use it. This year our contract is for 1 year, and they irrigate in this valley from about March 1st to mid-November. It coincides with whose hunting season it is, and so when they go on their hunting trip, they turn the ditch off. It is completely unmanaged and unregulated. So we don't want to have to manage this agreement throughout the full year. So we're just really targeting a 4-month window. So we're going to save, the 5 CFS. It comes out to about $10 an acre foot for this savings, which is comparable to other places. So just kind of some lessons learned over the past couple years with these guys is keeping expectations reasonable. When I first came into the Verde Valley, I wanted to say, oh, let's fix this, we can do this, we can do that. But it takes a lot of time, and there's a lot of social change that has to occur before we can do any of these projects. One of our biggest successes in the last few years was a field trip. We actually had all of the ditch bosses go on a bus to Phoenix, and we looked at other people's irrigation systems, and they saw how modern irrigation systems worked. They really liked some of those features and wanted to know how they could put them in place at home. So that's been one of our bigger successes, is getting those guys to talk. So with that, I will end if there's questions.
A question.
Right there.
I have a question about the cost. Is there like a cost per acre feet of what you've actually been able to save on this project?
Yeah, so the first project that we did, it was pretty, last year we saved about 2 CFS with our head gates was our estimate. And that was about $8 to $10 an acre foot for that project. With this next one, we used the kind of similar price. And we're looking at about $10 an acre foot, depending on what target they actually get to. So it's cost competitive.
Other questions?
I'll ask you. So you save the water. What do you do with it? It stays in what river? Or what's your benefit?
It stays in the Verde. So our flows are not going to benefit reaches downstream of the ditches. So we're not reducing the consumptive use in the Verde. We're actually just improving flows in the Verde Valley. So for that Diamond S project, it's a 5-mile reach that will have that benefit. For the Eureka Ditch project, that will probably benefit an 8-mile reach. So the whole Verde Valley is 40 miles, and each one of these projects really only benefits the reach that's associated with that ditch. So what we have to do is combine those projects. We have to be able to work on that whole reach. Because if we save water on the Eureka and it's just taken up by the Verde ditch, for example, our saved water is about 2 miles. So that's where it's important that we're working with each one of the ditch companies. So, yeah.
Any other questions? Nope. All right, thank you.
Okay.